Part C. Because the dehydration reaction is not observed to occur at 298 Kelvin, the student claims that the reaction has an equilibrium constant less than 1.00 at 298 Kelvin. So I'm going to underline the student's claim. Do the thermodynamic data for the reaction support the student's claim? So in other words, we have to find delta G and then see if the underlying statement makes sense. If it's yes, then you say yes. If no, then you say no. Justify your answer, including the calculation of delta G 298 Kelvin for the reaction. Yes, you have to use this delta G to find spontaneity here. So remember the delta G formula goes delta H minus the product of the temperature in Kelvin times delta S, the measure of disorder. So something you have to be careful. So I already wrote these values to save our time. 45.5 kilojoule, and that's for delta H. However, on the delta S, you're gonna notice that we have joule. So in other words, we cannot combine the kilojoule with joule. We have to convert the units. You can either convert the kilojoule to joule or joule to kilojoule. Here, I'm gonna just make it 45.5. Everything in joule. Minus 298 Kelvin. Okay, you notice that the Kelvins cancel out. And we have joule per mole of reaction, so everything good. Okay, when I subtract this, I get 7952. 7952 joule per mole of reaction. Sig fig is not so important here. If you want, you can, if you really want to go with sig fig, you want to convert this in kilojoule and use the subtraction sig fig rule, and I believe you get like an 8.0 kilojoule per mole. Okay, what's important is the delta G is definitely greater than 0, so it's non-spontaneous. So to answer part C is yes. It supports the student's claim based on our calculation. Okay. Actually, no, I'm sorry. This is only the spontaneity. We still haven't done the equilibrium constant. Okay, to get that, we have to use another formula. That is delta G naught equals negative RT ln K, and let's see if the K becomes less than 1. We know the R is 0.08201, 0.08206, and T is 298, and we just found the delta G. Okay. But to find the K, we're gonna have to, let's first divide it. Negative RT, so RT's cancel out. You get ln K equals negative delta G naught over RT. Now to get the K, you have to put the E on both sides, because ln function and the exponential are inverse to each other. K equal E to the negative delta G naught over RT. Okay, I don't use this one this time. I gotta use 8.301. 8.3145 joule per mole Kelvin, and the temperature was 298. And you see the joule there? This time I'm gonna use 7952 joule. Okay. And that's gonna be also mole reaction. So I go to my calculator, and 7952 over 8.3145 divided by 298, and then e to that, I get 0.040. So let me write our value. Okay, the K equilibrium constant is 0.0403. Therefore this is less than 1, and this completely justifies the student's claim. You've seen the underlying statement here. The reaction has an equilibrium constant less than 1.00 at 298 Kelvin, and it's less than 1. Yes, it's non-spontaneous. Everything agrees.